Hello, welcome to this presentation of MQTT. MQTT stands for Message Queue for Telemetry and Transport. It's a protocol for communicating between two devices. Basically, it's a protocol for what we are calling M2M, machine to machine, and it also really used for another things, which is IoT, Internet of Things. So when I say that, you say, okay, I'm not especially interested by a protocol to communicate between machines because I'm developing application like web application where there's human interacting. And I will say to you, okay, take a look to the greatest example of MQTT and you will see that you are using it daily. This example is Facebook Messenger. In fact, each time you are sending a message to one of your friends, you are evolving the MQTT protocol. And so it's machine to machine because it's two cell phones communicating together, but there is a human on the end of each cell phone. So why does Facebook shows this protocol? It's because when you are doing mobile and IoT, you have to deal with some challenges. The first one is the small bandwidth of the network. You have 3G, you have Edge, you have GPRS. They are slow network. Even if 3G looks good, when you enter a building, for example, the quality can decrease a lot and the bandwidth really decrease also. Those networks are not reliable. An example is a car entering a tunnel. You will lose the connection. Or yourself, who enter in a building with your cell phone, you can lose the communication or lost a lot of packets because of the lower quality you get at this point. For many equipment, many communication, you have to pass through different filtering equipment like a firewall or router doing network address translation. Then when you are on mobiles, you really like to have some push notification, meaning that you want to get incoming message or eventually to be able to control the configuration remotely. The last point, which is really important also, is the environment. You have to support a lot of different devices. That's a particular example in a mobile environment where you have Android based on Java or iPhone based on Objective-C. But you can also have to support standard terminal with JavaScript or x86 environment, ARM, and so on. So the protocol you want to use have to support all these complex environment. Let's take a look why MQTT is a solution for this. What about the network bandwidth required to make MQTT working? It's really small, about 10 kilobytes per hour, and you are able to maintain an MQTT communication. This MQTT communication will allow you to have a push, publish and subscribe solution that can realize the push system you need to have. MQTT is reliable. We'll see that in detail later, but you are managing quality of service. So it means that even if the quality of the network is poor, even if you pass through a tunnel, you will be able to transmit your information over MQTT. MQTT built over TCP. It means that it is able to pass through all the network standard equipment. It supports NATing, for example, and pass through firewall if configured to pass through. You can manage publish and subscribe. That's something I already in detail. And what is also really interesting is that MQTT is implemented over a really large number of platforms and language. So it means that if you start your project with MQTT, you're sure you can develop it on any device, any cell phone, any embedded system, or any standard desktop environment. Let's take a look to the usual MQTT architecture to introduce one of the important things to consider in MQTT. MQTT have a central part, which is a server. We also name this server a broker, in fact. It's a central node of communication. It means that anything else is a client. Your mobile is a client, two mobile communicating together are two clients connected to a MQTT server. A web application, a front end, is also a client. Okay, so you have a broker in the center of MQTT environment. For this broker, the main server to use is Mosquito. So you can get it on mosquito.org. But you can also use SaaS server, like for example CloudMQTT.com, which is in fact an implementation of Mosquito on Amazon Web Service. And what is also interesting in MQTT is that if you need to create a really scalable service and with failover, high availability and so on, you can also use dedicated appliance like DataPower message site, and you can process up to 13 million messages per second, just to give you an idea of the limit you can have in this area, and to say that in fact there's no real limit as you can multiply appliance if you want. The other thing I really like on MQTT is the easiest way to use it. I mean, if you want to start Mosquito server, just run Mosquito and you get it, and you can start play with it. No time spent on complex configuration to discover it and to play with it. On the client side, the client's role is to open a communication with the broker, to maintain this communication. Then a client is publishing message over topics. We'll detail that after. And a client is subscribing to topics, meaning that a client will be able to asynchronously receive a message from another client. For the client implementation, one of the most famous implementation is Eclipse PAO. Eclipse Foundation has decided to provide Java, C, and JavaScript clients for MQTT. But you can also find lots of other client implementation. You have .NET, Objective-C, C++ implementation, and many scripts, Ruby, TCL, and so on. For the platform, as I said, you can find many platforms. Arduino is supported, Mbed, Android, Raspberry, Linux, Windows, and others have clients for MQTT. Sorry. With MQTT, you have multi-way of communication. You can communicate between one client to another client. It's like your chat. You can decide to communicate to one client to many clients. You can decide to have communication from many to one. Many to one is like a sensor communicating to a central system. And also many to many, meaning that you can have, for example, multiple sensors communicating to multiple servers, and eventually you will specialize servers regarding services you want to do. The advantages is that you can start from one-to-one system, change it after for one-to-many, then have many-to-one, and at the end many-to-many. It's just a configuration of your clients, in fact. And there's nothing about a protocol or broker that can limit you on that way. Here is an example on how to code MQTT. This is a C example. I like this example because it's really a short example. You see there is main, you create a Mosquito structure, you initialize the library, you create a client, you connect to a server, here is localhost, then you subscribe to a topics. Here the topic is my/topic/2/subscribe, and then you create a callback to a function on message. So it's only a couple of lines of C you have to write, and at this point, each time one client will send a message to my topic to subscribe, this message will be processed by the on message procedure you have on top. Okay, so you will see that in a live demonstration just after, but it's really easy to implement, easy to set up. Let's talk a little bit more about MQTT. MQTT, you can say that, oh, it's M2M, it's IoT, so it's something really new, it's not stable, and so on. I never hear about it, so yeah. In fact, all of this is false. MQTT is something really old now. It has been developed at the end of the 90s. It is supported by IBM and Eurotech, which are both big companies with, I mean, they are doing quality things. So, meaning that MQTT is something really stable now. We are talking a lot of MQTT now because of IoT and M2M trends, but also because Eclipse Foundation has decided to use MQTT as part of its mobile-to-mobile strategy in 2011. And now, I think it was last week now, MQTT is becoming an OAG standard. So it has been validated as an OAG standard. So from my point of view, these elements are really interesting. If we are looking to the different protocol used for M2L and IoT, this is the main difference we have with MQTT, is all this standardization and the support by a big player like IBM. Now, let's take a look on some detail of this protocol. Let's talk about message format, what is topics, how it manages the quality of service, and the security point. The message format, here it's really easy. Do as you want. This is a really good thing. If you want to use JSON, use JSON. If you want to use plain text, use plain text. And if you are crazy and want to use XML, yeah, let's just do it. I think is a strength of this protocol. It's that you are doing what you want with it. You are transporting what you want. A message can be something like 256 megabytes, so it's really huge, and I mean it makes no sense to have a message like that. But you can choose. If you have already some messages existing for communicating between applications, you can reuse these messages. That's a good thing. Here is another example of how to publish data with MQTT. It's a Python example. You see that with a 4-line, you can start sending message over MQTT protocol. Well, that's another way to say that it's really simple to implement. Now, topics. I've talked a lot about topics. What is a topics? In fact, topics is a queue, or we can say that it's a kind of mailbox. It's an ordered mailbox. This mailbox is organized, are organized in 3 organizations. It can be used, for example, for group and sensor. If I want to organize my sensor for my house, for example, I can have a tree, like house will be pole, floor can be first floor, a room can be a dinner room, and sensor can be temperature, pressure. Okay, I mean that those topics are plain text topics, and I will create the organization I want. Basically, we have 4 levels in this tree, and we can decide to put what we want. The advantages of those topics in this tree organization is that you can use wildcard to do some search really easily. So it means that if I want to get information from my host, so Paul, I can use Paul/plus, and I will get all the information for whatever the floor is, whatever the room is, whatever the sensor is. In another way, if I want to get temperature from everyone, I can have something like ////temperature, and I will get all the temperature elements from any other's mailbox. Okay, so it's a kind of really easy to use CQL solution. I mean, you can get filter and select the information you want, and yeah, it's easy to use. Basically, anyone can publish to to one topic or more. So one client can send information over many topics. And eventually, you can have multiple clients writing to the same topics. It's not a problem. In the same way, anyone can subscribe to a topic or more. So it means that a client can subscribe to a topic, 2 topics, 10 topics. And 2 different clients can subscribe to the same topic. That's flexible. Next thing is quality of service. My point of view, quality of service is really important in mobile things. And MQTT here at this point is really saving the developer time. We have 3 levels of quality of service. The first one is interesting, is quality of service 0. It means that the message is published. If you have any problem in the network, the message is lost. And if you have no connection at the time you want to publish the message will be directly dropped. The advantages of this is that when you get back on network, you are not spending all your energy and bandwidth to publish old and not interesting messages. They will be lost. But sometimes you have to deliver a message because it's an important message. In this time, you have 2 choices of quality of service. The first one is quality of service number 1. It means that you publish the message and you get an acknowledgement. If you do not get this acknowledgement, the message will be sent again. And this mechanism is managed by the client. This is really important because developers don't have to manage that. It's the MQTT client who is managing this publish and republish mechanism. It means that there is an asynchronous processes working on background to manage the queue of those messages and the republishment when necessary. The matter with QoS1 is you publish, server gives you an acknowledgement, but you can lose this acknowledgement. It means that you have published your message, but you are not aware, and you are publishing it again. And so the broker will receive it a second time and give you another acknowledgement. So with quality of service number 1, you can have multiple delivery of the same message. To solve that, if it's a problem to you, you have the quality of service 2, and in this case, you have a double acknowledgement to ensure that your message is published and published only once. On this slide, you also see one thing. QoS0 is really small communication, really easy, and you are quite sure that something will be delivered if you have the sufficient bandwidth. QoS1 is a double. QoS2 is 4 times QoS0 message. So it means that you have more risk to have some loss or difficulty to send message over QoS2. Okay, but MQTT implementation is really network optimized with small frame and so on. So it gives you many more chance to have deliveries than another protocol. And the main point is that all of this is managed by the client. So you don't have to care in detail of this. The last point, it's really important point also, is security. Basically, if you do no configuration, you have no specific security. The security is made at topic level. For each topic, you have rights and authentication, so you can decide who can read, who can write on the topic. So basically, everyone can read and write any topics. So you can implement some security rules. The first and easiest one is to have a user and password, and for each user you have rights per topics. And if you want to do something better in terms of security, you can use also SSL communication and certificate authentication, so you can have really a safe environment over MQTT with no problem. Now, I will show you a demonstration of a MQTT implementation. The objective is to show you how in about 4 minutes you can implement, you can run MQTT, and to demonstrate this quality of service management. So when you want to start with MQTT, the first thing is to get Mosquito. So I'm gonna simply download Mosquito from the website. So get it, unpack it, and then compile it. Okay, so you see that it's not a big library. It's really quick to install and to use. So when that's done, let's say now we can start a Mosquito server. Broker is up and running now. I've done the configuration. Now I will start 2 clients. They will subscribe to 2 topics. One will be topic 1, and on this one we'll have quality of service 0, and the second one is will be topic 2 with a quality of service 1. So you see here I use topic 2 /dash. It's the wildcard to complete all the subtree. Now to publish message, I'm writing an example from scratch to show you. So a Mosquito structure is created, the library is initialized, and the publisher, that's the name of my client, is created and is connecting to the broker. The connect is asynchronous, and we have a loop start. This means that we're gonna have a thread running in background, and this thread will manage the resubmission and so on. We have the quality. So then I'm creating 2 messages. One message is a quality of service 0. The second message will print an ID with quality of service 1. And now we are publishing the 2 messages. First one with quality of service 0 over topic 1. And the second one will be on topic 2 with the quality of service 1. And we will have an infinite loop with a sleep of 1 second. It means that we can see an increment in the message every second. So I'm compiling now this demonstration program. Okay, and I'm starting it. So once it starts, you see that the subscriber are receiving the message. Every second we get a new message. Here on quality of service 0, previously on quality of service 1. Yeah, you see it's quality of service 1. And now what I'm going to do is to kill the Mosquito broker. It means that my publisher cannot send anything. There's no broker here. It's exactly like if the client passed through a tunnel. When I restart the broker, I can see that on quality of service number 1, I've lost no message. It means that the client have kept the message in memory and want the broker to be back to send it again. In quality of service 0, you can see that the message are moving from 19 to 38, so about 10 messages have been dropped at this time. To continue the demonstration, I will do the same thing by killing the killing the subscriber, and restarting it, and we can see that there's no loss. Message have been sent by the broker when the subscriber is connecting again. So it's like if a web server, application server, is disconnected from the broker, when it's back, you get all the messages. In quality of service 0, as you can see right now, it's as usual, messages are lost. So, our last slide to show you why MQTT, in fact, is really interesting compared to some other protocol like the one you can have the use, that it is HTTPS. This is a study that's been made. Frankly speaking, I don't remember exactly where I got that on the internet, but it was really interesting. This study has sent about 1 kilo message over MQTT and 1 kilo message over HTTPS on a 3G environment. The first really interesting thing is to say that on MQTT protocol, all the message that has been saved as sent has been received. On HTTPS, only 1/4 of the message sent has been received. That's a problem in a communication environment. It's interesting to see that. The other thing, which is really interesting, is to see that if you take a look to the time spent to send the message and you do a projection to say how many messages we can send per hour, you see that there is a huge difference between MQTT and HTTPS. It does not mean that you want to send 160k message per hour, but it means that the time to send a MQTT message is really, really small compared to the time to transmit a message over HTTPS. This is why it is normal to lose some message over HTTPS and 3G because the duration of the communication is a high risk if you are in a non-reliable network connection. And the other point, which is also important and in relation with that, is the battery consumption. As your message, the time to send a message on MQTT is really smaller, you are consuming about 100 less than HTTPS to transfer your message. 100 less. So it means that with this protocol, you are preserving the battery of your device. So now I hope that you have a good idea of what is MQTT. I hope that you will be happy to start some development with this protocol. And if you have any question, don't hesitate to post some comment on my website www.dask91.com or to contact me on Twitter on my dask_91 account. I will be happy to continue discussion online. Bye.